Hey, how you doing? We're talking about ratios today. We're talking about simplifying ratios. As you can see from here, we have a few examples and a couple of notes to keep in mind when you're simplifying ratios. Number one, that divisibility is really important. We talked in class about how the divisibility rules, such as the 2 rule being anything that's an even number that ends in 0, 2, 4, 6, or 8, is divisible by 2, and all the other rules that we talked about, especially the 3, the 5, the 6, the 9, and the 10, those are very important in reducing a fraction, whittling it down to its simplest form, to express it in such terms when asked for it, especially when we're talking about completing math operations with fractions. It's probably always best to start off with the simplest form fraction so that you can work your way from there. Sometimes it's necessary to work your way backwards. We call those equivalent fractions or ratios, and we get to those later on in the course. By looking at the examples right here, we're talking about how different types of ratios can be simplified, and there are a few different methods here. You might want to expand your video window a little bit to see this. I know this is written a little bit small, and I do apologize for that. When you're taking a look at a colon ratio, 12 apples to 60 total fruits, you can see that just by using divisibility and realizing that these are both even numbers, we can determine that since they're even numbers, they can be divided by 2. That leaves us with a ratio that looks similar to 6 to 30. And I see that 6 and 30 are also even, so I can do the same thing again. When I do that, I am left with 3 to 15. Obviously, neither of those is even, but I can still work through that and find another number that might divide into both of those, like 3. The 3 divisibility rule makes sense for this. This is obviously 3, and 15 follows the 3 rule because 1 plus 5 equals 6. By adding those two place value digits up and having a number that is a multiple of 3, that does prove that it follows the 3 divisibility rule. And by doing that, we have 1 to 5, and the answer is 1 to 5. And another way that you know that you have gone as far as you can go is that by looking at both numbers, comparing both numbers to the highest number that they have in common in terms of a factor, the greatest common factor, by knowing that the GCF is 1, you know that you went as far as you can go, and it should be in the simplest form. Looking at some other examples here, we have a fractional example. We have another ratio example using words instead of using a fraction bar, which denotes division. By finding that 14 and 21 have a common factor in 7, I know it's not a divisibility rule, but you have to go through all the possible numbers, and by looking at that this is not divisible by 2, this is, and this is not. Neither of these are divisible by 5. 3 would work for this, but would not work for this. You can see that you can kind of almost have like a yes-no progression through those very small numbers and use those divisibility rules to your advantage. In this instance, 7 works for both of them, and 14 divided by 7 is 2, 21 divided by 7 is 3, and you can say that the answer is 2/3. 2/3 can't be simplified because the greatest common factor of 2 and 3 is 1. Taking a look at this example, it's solved very similarly to the first example, just the words are a little bit different. We see that they're both even numbers, and I always say start small. Start with the smallest possible number that will divide into both of those. Obviously, you can't use 1 to simplify it, but you can try 2. And since both of these are even, you can see that you could start there at least at 2. Could you start somewhere else? Of course, you could start at 3. For this example, you could probably start at 6 as well. If you know that the 6 rule states that the 2 and the 3 rules are followed for that. For this, I started at 2, and I can see that it's 9 out of 21 simplified. It's not quite there yet, though, because these look like 3 facts. They're in the 3-fact family or the 3 multiplication table. And by dividing both of them by 3, I get 3 out of 7, which is a simplified answer. Just to go back to some of the main tenets of simplifying, we want to think about reducing. Think about what you heard in the elementary school. Your teachers called it reducing. You were simplifying. You were using common factors to find a fractional answer or a ratio answer in simplest form. Think about your divisibility rules. Think about how whatever you do to the numerator, you must also do to the denominator, and those are just words that describe the top number and the bottom number in a fraction, or if you're thinking about a ratio, the first number and the second number. Maintain that balance, do the same thing for both of them, because if you use different factors to divide out, you're going to get the wrong answer. You're going to get something that's a lot different than what it's supposed to be. The value of the ratio or the fraction will change as a result of doing that, and we want to stay away from that. Have a great day.